Welcome to Chibuzor Mathphysics. In today's video, we continue our Eigenvalues series. So our aim today is to continue our Eigenvalues series. So how can we find the Eigenvalues of 2 by 2 matrices? We have 5, we have -1, we have 2, 2, and we are expected to find the Eigenvalues for this 2 by 2 matrix. For this 2 by 2 matrix. So let's see how to do that. So this is our matrix A is equals to 2, -1. We have 22, 2, 2. Okay. You might need to record the formula that it is A minus lambda I is equal to 0. If it were to be a 3 by 3 matrix, I should have introduced the new formula that I used in the last time. You can watch the previous video on how to find the eigenvalues of a 3 by 3 matrix. This is a 2 by 2 matrix. Of course, this matrix is of the order n by n. N by n simply means that it is equal to the number of rows is equal to the number of columns, and that is why we can be able to find the eigenvalues. Because for you to find the eigenvalues of any matrix, that matrix must be of the same order. If you have 3 by 2, then there will be you will find difficulty in finding the eigenvalues. So using this formula, we know that what we simply have here, we have our matrix A. Matrix A is given by 5, -1. We have 2, 2, as we have indicated above here. So this is minus lambda multiplied by the identity, I meaning the identity, so it is 1, 0, 0, 1, and this is simply the identity matrix. Multiplying this inside here, we will simply have, if we multiply lambda by 1, we get lambda. We have 0, 0, lambda. So this is what we have as our identity matrix. So therefore, this will imply that our new matrix A will be 5 minus lambda. 5 minus lambda. Then we have -1. We have 2 minus lambda. Then we have sorry about that. Here we simply have 2. This is 2, and then we have 2 minus lambda. So this is our new matrix A. This is our new matrix A, and we have to find now the determinant of this matrix and equate it to 0. So this will help us to find the eigenvalues for this. So to do this, we simply need to open up it. You know how to find the determinant of 2 by 2 matrix. It is simply 5 minus lambda multiplied by 2 minus lambda. We have 2 minus lambda minus, we have -1 times 2 is still -2, so this becomes +2. So let's open up this. 5 times 2, here we have 10. 5 times negative lambda will give us -5 lambda. Negative lambda multiplied by 2 is simply -2 lambda. Negative lambda multiplied by negative lambda is positive lambda squared. So what do we have? We have 10. 10 minus, let's say, minus 5 minus 2 lambda. You can use your calculator to do that. I have calculator here. Let's put that value in this calculator and check. We have, let's clear the calculator, and then we have minus 5 minus 2. Minus 5 minus 2 will simply give us -7. So this is -7 lambda. -7 lambda plus lambda squared, and this is equal to 0. So we can rewrite this to be lambda squared -7 lambda plus 10 is equal to 0. This will help us now to use our calculator to evaluate what will be the value for lambda 1 and lambda 2. So let's use our calculator and do that. So we can put this in the calculator, but just before we put that in the calculator, if you observe something, you will notice that we did not include these two. That means if you put this in the calculator, the value for lambda 1 will be 5, which will be wrong. The value for lambda 1 shouldn't be that. So we're supposed to have included these two, because this is a constant 2 and we have 10 as a constant. So add them together, this becomes 12. So instead of 10 here, we are going to have 12. So this is simply 12, and this is also 12. So add that up, this becomes 12. We have 12 here. Let me write that down. We have 12. So this is simply 12 minus 5, and also plus 12 is equal to 0. So let's put this in our calculator. Bring the calculator on. This is our calculator, and we are trying to evaluate this equation. So let's go to equation mode. Go to equation mode. Equation mode is number 5, and this is of second degree. So let's take quadratic. This is number 3, and let's put this value 1 is equal to -7. -7 is equal to 12. Is equal to 12. So the value for x1 is 4, and then x2 is 3. So our lambda 1, therefore our lambda 1 is equals to 4, and our lambda 2 is equal to 3. So these are the values of lambda 1 and lambda 2. But then now that we have got the value for lambda 1, we can use this value to find the corresponding eigenvector. So stay tuned as I get rid of some of this in order for us to find the eigenvectors. Okay, so to find the eigenvector, we need to replace for lambda. Lambda is equals to 4. This is lambda 1. We replace 4 where there is lambda. So 5 minus 4 is going to be 1. Then we have -1. We have 2. Then we have 2 minus, let's use the 2 minus 4. 2 minus 4 is going to be -2. So we have -2. We are looking for eigenvectors, and to find the eigenvectors we need to introduce some c1 c2, which is equal to some vectors c1 c2, and this must be equal to 0 0. And now we solve this as a system of equation. To solve this as a system of equation, we will simply have let's clear this up this side. Of course, what we are looking for now is the eigenvectors. We are looking for the eigenvectors. Good. So what we have here is c1. Then we have, if we multiply this, is simply c1 minus c2 is equal to 0. Of course, here we have 2. This simply means it's 2c1 minus 2c2 is equals to 0. So finding what will be the value of c1 and c2. So let's take let's take c1 for instance. C1 for instance here, c1 will be equals to c2 when it crosses over to that side, which means that our value for c1 will be equal to 1, and our value for c2 will also be equal to 1. Why? Because we know that if we use this for instance and say that this will simply be2c1 will be equals to 2c2. If you want to get c1, you have to divide both sides by 2 by 2. So this simply means you have 1 1 as our corresponding eigenvector for x1. So then we need to find a corresponding vector for lambda 2 when lambda is equals to 3. So replacing our value the same way we did in the first equation, when lambda is equals to 3, we simply have 5 minus 3 is 2, then we have negative 1, we have 2, then we also have 2 minus 3. We have 2 minus 3, that will give us negative 1. So this is a negative 1. This is negative 1. Negative 1. And this will be equal to the C4. We introduce some C4, C5. Since we have C1, C2 here, we can call it C3, C4. We can call it C3, C4 as our vectors. So this becomes C3 and then C4. Since we have C1, C2, and this must be equal to 0, 0. So change this to some system of equation. You have 2C1 minus C2 minus C2 is equal to 0. It's the same because the second equation is still 2C. This is 2C3. Remember, we're using C3 and C4 minus C4. So the second equation will still be 2C3 minus C4 is equals to 0. So what will be our if you evaluate the value for x2, 2C3 will simply be equals to C4. Of course, divide both sides by 2 by 2, so that we will have C3 to be equals to 1 over 2, which will implies that our x2 is simply 1 and 2. And this is how you can find eigenvectors and its corresponding eigenvalues.